Last week I showed you what a stock Flipper Zero can do. Today we're voiding that warranty, figuratively, by adding this. This is the official Wi-Fi dev board. It clips onto the back, adds a full ESP32 chip, and turns the Flipper from a radio toy into something that can run actual network attacks, fake login pages, deauthentication, packet capture. I'm going to show you how the whole system fits together, set up an evil portal on my own home network, and show you exactly what it captures. And exactly why this matters if you manage any network at all. Own hardware, own network, full transparency. Let's get into it. Welcome back to the Tinkerer's Lab. If you caught last week's video, you already know the Flipper. If not, there's a link up top, but you don't need it to follow along today. Quick heads up before we start. Everything in this video is run against my own router on my own network. I'll explain why that matters later. For now, let's get the board talking to the Flipper. So what's actually on this thing? The Wi-Fi dev board is built around an ESP32-S2, a tiny cheap microcontroller with built-in Wi-Fi that you'll find in everything from smart plugs to DIY weather stations. On its own, the Flipper has no Wi-Fi hardware at all. The sub-gigahertz radio we used last week tops out well below Wi-Fi frequencies. This board fixes that gap. It slots straight onto the GPIO pins on the back, draws power from the Flipper, and talks to it over a serial connection. Once it's attached, the board is ready to go. If you're running Momentum, the ESP apps are already there. Head into Apps, then ESP, and you'll find individual apps for Evil Portal, Deuth, Packet Sniffing, and more. Each one is a separate app that talks to the board over a serial connection. The apps live on the Flipper. The actual Wi-Fi work happens on the board. Before we get into the demos, let's cover how the firmware setup works, because there's a distinction worth understanding. Marauder doesn't run on the Flipper itself, it runs entirely on the ESP32 chip on the dev board. That means whatever firmware your Flipper is running, stock, Momentum, Unleashed, it doesn't matter here. The Flipper just talks to the board over serial and acts as the display and controller. Marauder lives on the board. To flash the board, you connect it directly to your computer over USB, not through the Flipper. There are a few flashing tools around, but the easiest right now is the browser-based one from the Marauder project, which uses Web USB. No drivers, no software to install. There are two main easy ways to flash the Marauder firmware via Web USB. Easiest way is to flash via FC Flasher. The link to the website is in the description. Before you flash the firmware, press and hold the boot button and connect your USB cable. Then navigate to FC Flasher website. Then click Connect. A menu will appear with all the connected devices. Select ESP32-S2 and click Connect. Select your board variant, S2 for the official Flipper Wi-Fi dev board. Point it at the latest release and firmware and hit Program. The board will reset itself once or twice during the process. That's normal. The whole thing takes 2 or 3 minutes. Once it's done, you reattach the board to the Flipper, head into Apps, then ESP, open any of the Wi-Fi apps, and you should immediately start seeing results. Networks populating, signal strength updating in real time. That's your confirmation everything's talking correctly. From here, every feature we're covering today is a few button presses away. Now for the headline feature, Evil Portal. Here's the concept. The Flipper broadcasts its own Wi-Fi network, something that looks legitimate, like free office Wi-Fi or a hotel name. When a device connects, instead of getting real internet access, it gets redirected to a fake login page that the Flipper is hosting locally. The Evil Portal app comes with a handful of pre-built page templates, a generic Wi-Fi login, a Google-style sign-in, a router admin page, They're HTML files that sit on the flipper's SD card so you can swap them out or build your own. Pick one, name your access point, and hit start. On my phone here, I can see the fake network show up in my Wi-Fi list. Looks completely normal. I'm going to connect to it now, on a phone that's not logged into anything important, purely to show you the flow. And there it is. A captive portal pops up automatically, just like the Wi-Fi login page you'd see at a cafe or airport. If I type anything into these fields, it goes straight back to the flipper in plain text the moment I hit submit. That's the entire attack. No malware, no exploit, no hacking in the traditional sense. Just a device asking you for your password and you handing it over because the page looked right. This is exactly why it's called social engineering rather than hacking. The vulnerability isn't in the software, it's in the fact that most people don't check the network name before they type a password into a pop-up. The second feature worth covering is deauthentication, usually just called deauth. Every Wi-Fi network sends out small management packets behind the scenes to keep connected devices in sync. A deauth attack abuses that system by sending fake disconnect packets, telling a device it's been kicked off the network, even though it hasn't. Here, I'm connecting to my test Wi-Fi network, which has a WPA1 password. Then I will navigate to the Marauder app and scan for available Wi-Fi access points. And from the list of access points, select the ID of the access point you are attacking. In order for us to capture a successful handshake, we need to force a user to reconnect to the network. Therefore, I will launch a deauth attack on the selected network. Here, you can see the phone immediately disconnects from the network. Then I launch a PMK-ID sniff on the selected network. Note that when I reconnect my phone, the flipper instantly captures the handshake. After that, I save the PCAP files to my flipper's SD card. Then I open Flipper Lab to download the saved PCAP files. Navigate to Flipper Lab, connect the flipper via USB, and click Connect. Then click on Files, Ext, Apps Data, Marauder, PCAP, and download the PCAP files. I will be using the rockyou.txt from WeakPass as the password list, and I am using Aircrack-ng to run the passwords list against the PCAP file I downloaded. I will include the links down below for the password list and Aircrack-ng installation. Then run Aircrack command, which might take a few minutes depending on your computer specs. Eventually, Aircrack will reveal the correct password. If the network password is a common word, a name, or anything that appears in a dictionary, Aircrack finds it. This is entirely offline. The router never sees it happening. This is also why password 123 and your dog's name are genuinely terrible Wi-Fi passwords, and why WPA3 was designed specifically to close this gap. WPA3 uses a different handshake mechanism that isn't vulnerable to this kind of offline cracking. The second use case is what we already covered, combining deauth with evil portal. Here you're not after the Wi-Fi password at all. You're knocking the device off the real network and hoping it connects to your fake one instead. Same starting move, completely different goal. One is cryptographic, the other is psychological. Both work, and both are exactly the kind of thing a network administrator needs to understand to defend against them. So, that's the Wi-Fi dev board. Evil portal for credential harvesting demos, deauth for disrupting connections, and packet sniffing to see what's actually floating through the air around you. If you found this useful, subscribe for next week's bad USB deep dive, and I'll see you then.